3D printing is an incredible tool, but in my opinion, it's just that. Another tool in your making arsenal to create amazing projects that rotate, roll, and reciprocate. I have made countless projects over the years combining electronics and mechanics with 3D printing, and I thought it'd be fun to share my tips and tricks in a video on how you can do it too in a reasonable time frame without blowing your budget. Let's get started. How's it going, guys? Angus here from Maker's Muse. This is the version 2 off-road platform for the wacky wheel testing, and it's been a long time coming. What you see here is the culmination of a whole week of CAD and prototyping and testing. But what do I mean by electromechanical projects anyway? Well, this thing is remote controlled. So it has a battery, it has controllers, speed controllers, it has motors, it has a receiver that communicates with a transmitter. It's got electrical components that interface with mechanical components like bearings and gears to then drive this machine forward through the 3D printed wheels. And it's an art form to make these worlds together in a seamless package that plays nice and actually works. And finding the parts you need to build projects like this can be incredibly frustrating. It can be very expensive and time consuming to find them and then acquire them to put them into your projects. Although I've only recently introduced remote control platforms on Maker's Muse, I've actually been building stuff like this for a very long time. When I was in early high school, I got interested in combat robotics, and I would build remote control combat robots to fight in the Australian Robo Wars competitions. And they are essentially very similar. Remote control platforms that need all sorts of electromechanical components to interact correctly for them to work. But being in early high school, I was incredibly broke. And it was at this early stage that I started developing my approach to prototyping projects like this at a timely manner, but also effectively very, very cheap. It's incredibly easy to blow the bank looking for bearings and gears, pulleys, timing belts that you need quickly of a certain size, when actually there is different ways you can approach it to save a lot of money. However, the number one rule before you start doing anything, before you start touching 3D modeling, before you start buying any components, is to start conceptualizing what you actually want to make. And you do that by drawing it. I have so many notebooks, I've talked about it so many times on the channel. I draw all my concepts, I note them down, I figure out what I might want to use, I try to figure out if it will work or not on paper. This is free. And the more you do this, the more you figure out how things might assemble, how they might join together, the more you'll save headaches later on when you buy parts that don't fit, or you end up not needing them, or you end up designing stuff into a corner because you haven't thought about stuff early on paper. I'm not an artist at all, I can barely draw, but initially I wanted to use a long belt path and I was conceptualizing it here. And then I actually ended up going for a portal axle design, which some of you guys suggested on the previous video. And this book is full of just random concepts with side views, top views, of me figuring out how stuff will join together, and then noting down parts that I might need to purchase to then start prototyping this design. So first off, before you do anything, sketch your ideas and try to figure out how they're going to join together. Because if you don't do that, you are going to waste a ton of time and money. Next is to be aware of one of my favorite sayings when it comes to sourcing components. Good, fast, cheap, pick two. This applies to almost everything. It's pretty universal. It's pretty incredible in the fact that when you look at buying almost anything, you can kind of fit it into this formula. If you want something quick and it's high quality, well, you're gonna pay through the nose to get that privilege. You can wait a bit longer, well, it's gonna be cheaper. But if you wanna get something really quick and cheap, it's probably not going to be very good. This does hold up in a lot of circumstances, but not everything. Because when I was designing my combat robots back in high school, I learned an alternative to this, which is to adapt, repurpose, and modify. So for example, we needed drive motors for our robots to drive around, and these drive motors could be bought from industrial suppliers for hundreds of dollars. But a cordless drill has a high quality, robust gearbox in it that's battery powered that you can buy for $15 for the whole drill. So we would buy cordless drills, rip them apart, and modify them for use as gear motors. This is a good example of how you can sort of think outside of the box and think about how things that do exist at a lower price might be able to be repurposed and modified to be used in whatever project you're building. I will often just wander around hardware stores looking at items and thinking about how I can use them for a different purpose than what they're originally intended. And this mindset will save you a lot of money going forwards designing all sorts of projects. As an example for the off-road platform I'm building, I needed a way to transfer torque from the smaller pinion gear to the larger spur gear, and I wanted to have a aluminium hex that could bite into the spur gear that's 3D printed. So I could have gone and gotten some custom machined ones, but instead I bought more hex hubs that I used for mounting the wheels, and then I simply just bored through them even more, so they have a 6mm bore right through with grub screws ready to go that I can now use to mount my spur gear with a really strong hexagonal mating interface to then drive that torque to the wheel. So yes, it might be a bit of a waste drilling through a nice tapped hole to make it a through hole, but they're only $3 each, and this way I could get them really quickly. I don't have a lathe, so I could machine them myself, and I could reuse and repurpose something that already existed to move my project forwards. My next tip is to hoard, but hoard responsibly. I am terrible for hoarding random junk for years and years and years that I think in future might be useful for a certain project. And here's the thing, if you don't know where those things are when you need them, they might as well not exist. So when I say hoard responsibly, I mean if you know where stuff's stored, if it's organized and you can go find it. For example, I need to look in my bearing drawer for a few bearings, I know where that is, or I need some shafts, I know where the shafts are. That's fine. If you have a jar just full of random screws of assorted sizes and you need 4 small screws of the same length, good luck finding them. At the end of every project, you will have stuff left over, and if you do store it in an organized fashion where it's not taking up too much space, then I say totally go for it. Early on in the design process, I was going to use a timing belt to drive 2 wheels from one motor, so one on each side, and I did have all these timing pulleys and idlers and bearings stashed away because I didn't throw them away from previous projects, and also a lot of dead 3D printers. So in this case, organized hoarding did help me very quickly because I could just go downstairs, find the parts, didn't have to wait for shipping times. I could prototype and test and move forwards without having to worry about buying parts and finding out they weren't going to work. But I do have a rule these days where if something's not really worth that much, or it's not the highest quality, or it's going to be too hard to find in future, I will throw it away because there's no point having it stored away, again, if you can't find it when you need it. My next tip is to fail fast. So this is more of a business term. My dad does business mentoring these days. It's one of his favorite terms, and it does very much apply to prototyping for electromechanical projects as well. You want to test things as quickly as possible to figure out if they're good or not. Now, of course, you need to sketch down your ideas, and if you fail fast on the page before it even translates into a 3D model, that's going to be even better, but some things you do need to prototype and test them out before you can go back to the drawing board and then see if you need to improve them. So a good example again is how I interface the gearboxes to my frame. What I have in this box and this table behind me are all the prototypes leading up to my final design for this version of the off-road platform. And each of these prints probably only took half an hour to an hour each, and they were all iterations where I tested things and found out what worked and what didn't. And a good example of failing fast working well for my project was my approach to attaching the gearboxes to the main frame. So initially what I wanted to do is have them sort of snap in place like this, where the frame's here and the gearboxes are here, and they're really locked in place well, and 2 bolts come through the top to lock the whole thing in place. So this is the prototype printed in this orientation, these are printed in this orientation, works really, really well, and I was really happy with that. So then I did a quarter test of the frame with this design, but as many of you will know, 3D printing has its own inherent limitations. Printing in this orientation, because the frame is large, meant there was support material in here, and due to the differences in quality, tolerances, and that, this just doesn't really go in. Not to mention that the support material took forever to clear out, right? So I got to test out various components, but without going the full way and finding out this didn't work, I was able to fail, which is good, and go back to the drawing board and come up with a different approach. This new design uses a dovetail style slide, which comes in from the top, goes down, and now the bolts are on the bottom with slots for M5 nuts. Now this is much simpler, it's designed for 3D printing where there won't be any support material in that orientation, goes in like that, and then snaps into place. And here's the full version of the frame, and I have the same snapping component here. You can see the gearboxes will snap into place, and they're perfectly locked in with no support materials. So this is the second version, but I was only able to get here by testing and having the previous versions fail and learning from it. Next, I'd like to talk about 3D modeling and how I keep things distinct through the design and prototyping process. So what I like to do, as I said, is test small things independently and then combine them at the end. So for example, initially I wanted to test the size of spur gears printed out and how they meshed once 3D printed. So I did this really simple test of spur gears. It actually happened to make a really fun little fidget spinner toy style thing. But the main purpose of this test was to establish how strong and printable these gears would be in the real world. Because when you're in a 3D modeling space, you don't really know the scale of things. You know, that size, that length there could be a millimeter, it could be 10 millimeters, it could be 0.1 millimeters. It's really easy to lose yourself in 3D modeling. So I often will print things as like a reality check. And that's what this was here. And then I went to like designing the gearbox. So when I'm designing complicated things, I'm still kind of a lazy 3D modeler if I'm not going to be releasing the files. I'll often do body modeling, so I won't have too many separate components with mates. I'll sort of model bodies in bodies. And this is the version that I did before I realized that it wasn't really printable due to the support material. So when I changed it, I actually saved a complete new copy just in case this version was a complete disaster and I needed to go back. Now, yes, Fusion does have built-in revisions and stuff, but this is just how I work, and I prefer to keep them completely separate with copies that aren't related in any way, so I can completely butcher something and then go back to something that did kind of work. And then eventually I got to this final version here, but again, this had a few revisions itself too. So that's my tip for 3D modeling. Do things in small tests, and then when you're happy, start combining them, but also save copies as you go in case things go wrong and you need to revert back to a previous version. Again, Fusion does have this built in, but I like to save independent ones, that's just because how I work. Finally, I'd like to address sourcing components for your projects. At the start of this video, I did mention the good, fast, cheap mentality. That is very much true, but also, unfortunately, depending where you are in the world, you will have better or worse access to just parts in general. Now, Australia is rubbish for getting electromechanical parts. So these are just some Australian companies that I've found really useful for my project. This isn't sponsored in any way. These are just companies that have been good and that I'm happy to recommend. RS is amazing. So RS sells a massive range of electronics and mechanical components, and they are basically next day, depending on where you are. It might be the day after. I tend to source a lot of my fasteners through RS, but they do sell a heck of a lot of other stuff. But I tend to do that because they're the quickest, especially at the moment we're in lockdown again here in Sydney, yay. So they will send next working day, or otherwise it will be in their global stock, so 7 days, so keep an eye on that. But you can go through their whole catalog, they have heaps of stuff. Again, not sponsored, they're a little bit more expensive, but really, really fast. Next is Core Electronics, and again, they've been wonderful for how fast they ship. They're in Newcastle, and they send here, again, like next day half the time. I've relied on them heavily for a lot of the, wheel hubs and stuff like that. They sell Raspberry Pi stuff. They're really good because they show what they have in stock, and again, they ship really fast, and their prices are reasonable too, so a big shout out to them as well. Then for bearings, I came across these guys, Plague Bearings. They're in, Melbourne, I think, and I think they used to sell fidget spinner stuff, but I was looking for flanged bearings with a 6mm internal diameter and I couldn't find them anywhere. RS had a few, but they were like $10 each, but I found them on Plague for way cheaper, and they shipped again quite quickly. It was within a week. So again, I can shout them out too. And then for even cheaper, there's this random eBay store, which has all sorts of stuff. Now, I don't know if they always ship from Australia. It seems to be one of those China/Australia warehouse deals, but they did also ship quite quickly. I bought these with a 3mm internal diameter when I was going to use them for idlers. Didn't end up doing it, but again, they ship pretty quick too, so I can say they're decent for Australians. You can, of course, buy direct from China with AliExpress and a lot of eBay sellers, which will take a long time to get to you, but will be the cheapest overall. So if you know exactly what you need and you can wait a month to get it, then you can get it straight from China. However, if you're in the US, you don't have to worry about any of this because you have McMaster-CARR. They will not send to anyone outside the US, but if you're there, take full advantage. McMaster has the largest catalog of mechanical components I am aware of, and they will ship to you really quickly, and their prices aren't even that bad. It was actually when they used to kind of send overseas, we would do bulk orders from McMaster sent to Australia, and it would still be a fraction of the cost of what the local bearing suppliers would try to charge us. So yeah, I'm incredibly jealous and salty that you guys get access to McMaster and we don't, but there it is. Everything I've shown previous, you can get from these guys really quickly. So if you're building any kind of electromechanical project, definitely check them out if you have access to them. This off-road platform has been a long time coming. It's currently the last bits are printing right now, and I'm hoping to get the testing back underway. But again, we're currently in another lockdown, so I don't know how long it'll be till I can go back out and do that safely. Hopefully not too long. I'll keep you guys updated. And if you have any other tips and tricks for designing cool things in your 3D printer, I'd love to hear them in the comments below. And finally, if you want to hear more about how I used to build combat robots on a shoestring, I've got the new Maker's Muse Aftershow. This is a link below you can follow. It's currently completely free, and it takes you to my Podia page where I'm going to have a chat with you guys with some footage from my really old combat robot fights and talk you through how I used to build these machines using like steel I would pull from a dumpster, stuff I would find by the side of the road, throw them together and fight these machines, and how they'd often kind of win against much more expensive platforms. This is something I'm going to be doing going forwards because there's so much more stuff I want to share with you guys, but YouTube is just becoming more and more of a place for short, punchy content, and I want to share more with you, so link is below and you can comment there and share your thoughts and questions with me. So thanks for watching, guys. Look forward to seeing you again very shortly here on Maker's Muse. Catch you later, guys. Bye.